Hi, everyone. So in today's session, we'll be talking about the type conversion. So let me share my screen and then we start from there. Okay. I hope everyone can see my screen. Here we go. So this is the 23rd module. It's about the type conversion in PostgreSQL. So this is what we'll be talking today. We first see the overview and then the operator, functions, value storage, union case, and related constructs. And we will end with the select output columns. Okay, so first of all, I want to mention that in order for you to follow this session, you have to be able to have the knowledge about the data type in PostgreSQL, also the allowed operators and functions. So as you know, SQL is a strongly typed language. It means every data item, it has its associated data type. So you cannot have any data that doesn't have a type. Even if it's unspecified, unknown, it's still a data type. So what is a type conversion? It's a mechanism used by the Postgres parser to convert data from one type to another implicitly without us to convert it explicitly. So most conversion behavior in PostgreSQL is governed by general rules that a parser has to follow to do an implicit conversion, which we will be seeing in the following slides. So these rules, they will allow us the mixed type in expression to have only one result in one type, because sometimes you have some expression that have integer mixed with a string. In that order, we have the parser, the system has to convert those type implicitly for us, and then we will get the result. If it's not possible, then it will be in our duty to make sure that we convert it explicitly. Other than that, we get some error. So the scanner parser divides element into 5 fundamental categories, which are integers, non-integers numbers, also the strings, the identifiers, also the keywords. Okay, so there are also 4 fundamental SQL construct requires distinct type conversion rules in PostgreSQL parser. So the first one is function calls. So as we know, the PostgreSQL system is built with so many functions. So it's a set of many functions that we have the system of PostgreSQL. So what is a function? These are the characteristics of a function. A function can have one or more argument. Also, the function can be overloaded. So what does it mean to be overloaded? So when a function is overloaded means we can have so many functions with the same name, but the only difference between those functions will be the type of the argument, the data type of the argument, or the number of the argument we have in that function. So if you call a function only with the name, we not that will not really specify which function we are calling. Only if we have different the specific data type and the specific number of the argument, that time we know which function we are calling, because we'll be having so many functions that have the same name. So the second one is operators. Operators, they're like function. They can also have 1 or 2 arguments, and also they can be overloaded. The third one is value storage. So let's take example of insert and update. When we do that, when we insert or update data in a database or in a table, we are inserting a new value in that table. So when we do that, we have to make sure that those value we're inserting, they have the same data type as the target column that we have to insert those data. If they are not, then the parser will try to convert those data implicitly for us in order to insert in the target column. If it's not possible, so it will be in our duty to convert it explicitly. The fourth one is union, case, and related constructs. So since all queries from a unized select statement must appear in a single set of columns, so the type of those results have to be the same. So each select clause must match up or convert it to a uniform type of data. So union and case, they are the same. We have to make sure that the set of the result in that column has the same data type. Okay, so let's start with the operator type resolution. So these are the steps that a parser has to follow in order to do the implicit conversion. So first thing, the parser will select operator to be used from a system called PG operator. So in that PG operator, it will see which operator to use. Secondly, it will check what operator can accept the argument we give in a statement or expression. Because we have so many operators with the same name, so the parser will choose which operator to use based on the type or the number of argument we will give to the operator. So after that, the parser will look the best match, and then it will apply to that statement or expression. Let's see an example. There's a square root operator, which is we can write it like that, like this. This is the root, the square root operator. So in the PG operator system, this is the only operator that we have. So we don't get any confusion saying like we don't know which one to use because it's only the only one in the system. So there is only one square root operator defined in the standard catalog, and it takes an argument of a type double prefix or float. So this can assign the initial type of integer to the argument in this example. So what I mean is, let me do this. So if you see here, check this. Okay, let's draw. Okay, so here we have 40, and 40, it doesn't have any data type associated with it. So in this example, the parser, we implicitly convert this 40 in float because we know only the square root can take a float as argument. So yeah. Let's see explanation here. Let's close this one here. All right. So the parser does a type conversion on the operand, and the query is equivalent to select the root square root cast. So we are going to convert this 40 as a double, which is float, and then it will return a result. But for us, we will not see it because it will be done implicitly in the system. So the second example is a string concatenation. So this is the string concatenation symbol. We have the first argument of the type string. If you see here, I can show you. Let's go back, repeat station. So if you see here, this is a concatenation operator. And here we have a text, which is a string. This is the first argument. And the second argument is a div. We don't have any specified data type here. So it's considered as a unknown data type. So what the parser will do, it will convert this string into a text in order to have a one data type in output, which will give us this. We try to clear here what I have put here. Okay. Trying to get my my mouse. Where is it? Can't find it. Okay. Okay. So let's see the result here. Here let's go back. So here we have A, B, C, D, E, F concatenate, and we will see that the data type here it's text, because the first argument is text, and then the parser will convert this second argument to text, and then the result will be text. So the parser will convert the second argument unknown into a string, which is text. Okay, it's clear all, and then we go next. Okay, so the third example here, it will be absolute value that have this symbol alt. Let me show you. This is the absolute value symbol operator, and this is the negation operator. So the preferred type in numeric category is float. If you don't specify argument and that you pass that argument to absolute value operator, the parser will convert that value implicitly in float data type. So here is an example. We want to have the absolute value for -4.5. We didn't precise which data type is this -4.5. So the parser will convert it implicitly in double parsers, which is float 8. Yeah. Okay, so if we try to pass a value that is out of range of a float, we will have an error. So let's see which error we are getting here. Here we see that we're getting this error like this. It's out of a range of double precision, which is float. So this is not a float. The parser was not able to convert this value into float because it's way beyond the float capability or the float interval. So the float has from a certain number to a certain number. This is way beyond float. So the system cannot do a conversion implicitly. That's why we're getting this error. Okay. So next, so on the other hand, the prefix operator as negation is defined only for integer data type, not for float. So if we don't precise like it's integer, we get error saying that you may need to cast. You see here, we just give 20. 20 is not known, it's unknown. We have to implicitly say integer. If we don't, because this 20 is a numeric data type, and previously we saw that the preferred numeric in system is float. So when you put any numeric here, it should be considered as float. And for negation, we cannot use negation on float. So we have to convert this float in integer in order to apply a negation operator. All right. So let's try to convert this. Okay. So here we do a cast. You can see on this example, so we have cast this 20 as integer. And then here we be able, in that order, we'll be able to put negation in front of 20 because we converted explicitly. Yeah, so that's it for here. Let's see the next one. It will be function type resolution. The parser, we follow these steps in order to do function conversion implicitly. So as you saw in the operators, we have PG operator system. For function, the parser, we go to see which function to use in pgproc system. And then it will check which function will accept the argument that have been given. So if no exact method is found, and then if the function call appears to be the specific special type conversion request, and then it will try to convert it, and then it will look a best match, and then it will do the conversion for us. So let's take a look for an example. Rounding function. So there's only one round function in the system. So that round function, it takes 2 arguments. So in this example, it takes a first argument of numeric, and a second argument is a type of integer. So the following query automatically converts the first argument of integer into numeric. All right. So let me show you what I'm saying. So this one here is considered as integer, but it has to be numeric. So it has to be a numeric. Here, the parser, we convert this for, it will be like, it will do this for us, cast for as numeric, because here 4 is integer, and then it will do the round, and then it will return the numeric result, which will be like this. All right. So the rounding function argument. So since the numeric constant with decimal point are initially assigned to the type of numeric, as we said before, the numeric type is the preferred, the float. Float is the preferred numeric in the system. So if we put here 4.0, which is numeric, which is a float, at this point it's a numeric, so we don't need to do any conversion. Immediately this will give us a numeric result because round is accepting the numeric here. All right, let's see next. Substring function. So there are several substring functions. As we said, the function can be overloaded. When we say there are several substring, means we have the function with the same name substring, but they have different type of argument or different number of argument. So one of which takes type text and integer. So in this example, we have first argument is a text, and the second argument is a integer. So if called with string constant of unspecified type, The system chooses the candidate function that accepts an argument or the preferred category, which is a string. So when it's a string, then we'll be using text as a data type. So in this example, we chose substring. Here, 1, 2, 3, 4, we didn't specify which data type is, but the system will convert this implicitly in text because it's the preferred for the system when it's a string. So, and then it will do the result. The result will be text. Here, you can see the result is the type of text, even if we didn't specify that this is a text, but the system did the conversion for us implicitly. Okay, so here is the explanation. If the string is declared to be a type varchar, varchar as might be the case. So for example, if we are getting data from a database and we have declared, we have created database, a column, the type of varchar. So in that order, in the parse, we try to convert the varchar into text, and then it will give us the result. So in this example here, we can see that we have this varchar here. We have explicitly saying this 1, 2, 3, 4 is the type of varchar. So the parser is going to convert this varchar into text, but in behind scene, implicitly without us to know. Yeah. So, and if the function is called with an argument of type integer, the parser will try to convert that to text, but this will not happen implicitly because integer cannot be converted implicitly in string. So we have to do some cast explicitly on our end in order to be able to do this substring. So this is the solution. We take we cast this. Okay, no, go back. We cast this 1, 2, 3, 4, which was integer before, as a text. So once we cast it as a text, this is done explicitly with by us because the system cannot convert implicitly the integer to string. And then after converting that, here we see having a hard time to see my mouse. Where is it? Okay, no, I'm trying to see my mouse. Yes. No. Yeah, so when it's when it casts 1 to 3 in text, then we see the result will be the type of text. So the following type conversion is value storage. The value storage, so the values to be inserted in a table are converted to the destination columns data type according to the following step. So if we want to insert new data in a table, we have to make sure that that data has the same data type as the column we are targeting. So like insert, update, we have to make sure that the data we're inserting, they have the same data type as the column in the table of the data database. So these are the steps the parser is going to follow. It will check an exact match with the target. Otherwise, try to convert the expression to the target type. So this is possible if the assignment cast between the two types is registered in the pgcast. So here in the system, we have another catalog we called pgcast. So it will try to see if there is possibility to cast between the data that you want to insert in the column and the data type of the target column. If it's possible to convert those, to convert your data into that column, then they will convert it. So if there is sizing cast, then they will do that. If one is found in pgcast catalog, it will apply to the expression before storing into the destination column. So before the system or the processor, we first do the conversion before inserting data into the table. So here is the example. So character storage. Here we create a table called VV, and we give the column name V, which is a character of 20 characters. So here we are going to insert ABC and DEF into VV. So, and we will try to see the length of ABC, DEF. Normally, the length should be 6, because if you see here, we have ABC, we have DEF, it's 1, 2, 3, 4, 5, 6. But when we do the length of it, we see it's 20. So how so is it coming like that? We will see that in the following slide. So what is happening here? So the two unknown letters, which are ABC and DEF, they are known because we didn't assign any data type on them. And then we have assigned operator of concatenation. So we are trying to concatenate these two unknown letters and then insert them in the column called V. And this V, it has a data type of character. So here, when we do concatenation, it will be a text. Then the text result of the operator is converted to BPChar, which means a blank padded char. So the internal name of the character data type. So this is the internal name of the character type inside the system. So we are going to try to convert this text into BP char to match the target column, which is char. All right. So since the conversion from text to BP char is binary recursive, this conversion does not insert any real function call. Finally, the sizing function BPChar is going to be called. This is the function that will be called in order to do the sizing, get the right size, all right? So if it's found in the system catalog, we are going to apply that function and then the operator result and then store in the column length. So this type specific function performs the required length check and it's going to add the pending space. So here we have 1, 2, 3, 4, 5, 6 characters. But when we do the length, you see 20. Because of this function, BPChar integer Boolean applied to that, we are going to add extra blank space after the 6 character, meaning we are going to add 14 space, and then that's why we're going to get 20 characters. So this is what is a value storage type conversion. Hope you understood it. You understand it. So the other one is union case type resolution. So SQL union constructs must match up possibly with the type of the result. So when we do union on different expression statement, we have to make sure that the result will be the same data type, otherwise we have issue. So for example, these are the steps to follow. So if all inputs are of the same type, right, and it is not unknown, resolve as the type. So if we have a union of the type and all the data type are the same type, that's good, there's no issue, then the result will be the same data type. So if any input is of domain type, treat it as being of domain base type for all subsequent steps, right? If all inputs are of type unknown, resolve as type text is the preferred type of the string category. Otherwise, unknown inputs are ignored for the purpose of the remaining rules. So if the known unknown inputs are not all of the same type category, then it's going to fail. Select the first non-unknown input type as the candidate type. So then consider each other non-unknown input left to the right. If the candidate type can be implicitly converted to the other type from left to the right, then, but not vice versa, select the other type as the new. So if you can convert the left to the right, but not right to the left, then the right one will be the new candidate type. So then we continue like that. So convert all input to the final candidate type. Fail if there is no implicit conversion from a given input to the candidate type. So if there is no possibility to do a implicit conversion in those argument passed to the union, then it's going to fail. Then we have to do explicit conversion, or we have to change the data type. So here is the example. So let's see. We have A here, and is the data type text. We want to do union on with the B. B, it doesn't have a type. It's unknown. We don't know the type of B. So in that case, I lost my my mouse again. Okay, where are you? Ah, come on. No. Okay. Nothing. No, I don't have it. Okay, bear with me. Let me clear this first, and then let's go draw. Yeah. Let's go back. Okay. Here we are. We're here, I think. So we have A as type text. We want to do union with B, which is a known type. But here the unknown type literal B will be resolved to the type text because this is from left to the right. Is it possible to convert B into text? Yes, because it's literal. It can be converted to text. Then the process is going to convert A and B as text data type. Okay. Okay, let's go to the next. Okay, the next one is here we have 1.2. Oh no. Please go back. Okay. So here we have the literal 1.2, which is this one. We give it a name as numeric, and then we want to make a union on one which is integer. So 1.2 is of type numeric, and the integer value 1 can be cast to implicitly to numeric, so that type is used. So 1 can be converted to numeric, so we don't have any problem. Then we have numeric as a result. Here we don't have issue because from right to the left, the right argument can be converted to the left one. Then we use the left type. Okay, the third example is here we have 1. We want to do union 2. We are casting 2.2 as real. Can real be converted to integer? That's a question. Real cannot be implicitly cast to integer, but integer can be cast to real. Then the union result is resolved to a real. So we have to see vice versa. Can this be converted to this? If yes, then you are going to take this as a preferred data type. If not, we are going to see, can this be converted to this? If yes, then this will be a preferred data type. Other than that, it's going to fail. So we have to see vice versa. If it's implicitly possible, if it's not possible, then it will fail. But because real cannot be converted to integer, fine, then we don't have integer as a result. But integer can be converted in real, then we are going to take real as a data type of our final result. Okay. So the next example here, let's see where it is impossible, the implicit conversion. Here we have null, union selects null. Here we have like nested union, but this union here selects null, union selects null. This will be considered as inner. My handwriting is not good. This is inner union, and then this is outer union. Right. Good handwriting. Anyways, joking. So here we have error. Let's see which error we have here. They say union type text and integer cannot be matched. Because this one here, as we say, text will be the preferred for the system if it's unknown. So null is considered as text. And then we want to do text here. The result of this, it will be text. And then we want to concatenate to do union with integer, which will not be possible. So here we see come on. No. Let's clear everything. Then let's see the the explanation. This very no. Go back. True. Sorry, sometimes I'm losing my mouse. It is happening. So this failure occurs because PostgreSQL treat multi-union as a nest union. Okay. So this is inner one, and this is the outer, as I said. Okay. So we'll see the explanation in the next slide. So the inner union is resolved as emitted type text. According to the rules we just read above, the outer union has input of type text and then integer, which will be null and 1. So leading to observed error, the problem can be fixed by ensuring that the leftmost union, which is union, which is this one. Let me show you which one. So this one, the most left union has at least one input of the desired result type. So let's say here we want the desired type is integer. In order to remediate that, we have to put one here or here. One of them will resolve the issue. Okay? All right. And when we resolve the issue, then we will get the type of the result will be integer. Excuse me. Okay. So the last one is select output columns. So the rules given in the precedent section will result in assignment of non-unknown data type to all expression in SQL query. So all the rules we saw before, it will be applied to non-unknown database. So except of unspecified type literals that appear as simple output columns for a select command. So the hello world, it's express. We can see that it's a text. So it's even if it's not specified, it's unspecified literal. Here we say it's unspecified type literal, which is here, and we know that the preferred of literal data type is text. So automatically we get text as data type. Okay, so these are the data type conversion. I hope you understood. If you didn't understand, ask question. I'm here to answer. Thank you for your attention. Thank you very much. See you in the next session. Bye-bye.